Now in this second part we're going to talk about probability and simple math. So first we have a challenge that's just math. And when I used to teach game design, I'd say to the students, you all know you're not allowed to miss more than 15% of classes. We have 2 classes a week and there are 16 weeks. What is 15% of classes? Do it in your head. That was the important thing. Do it in your head. Most people can get this by working it out on paper with long division and so on, but not in their head. Some people can't even get 10% in their head, even though all you're doing is shifting the decimal point one place to the right. I wanted the students to try to do it in their head because this kind of thing should be second nature to a game designer. How do you figure it in your head? You don't do long division in your head. You find shortcuts. You do something easy. 16 weeks times 2 is 32 classes. 10% of 32 is 3.2. You've shifted the decimal point to the left, not to the right. I misspoke. Okay, now you have 10%, you want 15, so you want 5% more. Well, 5% is half of 10%. Half of 3.2 is 1.6. Add them together and you get 4.8 classes. Most people can't do that in their head, and I'm talking about college students. They certainly should be able to, but our schools have not for a time supported this kind of capability. Okay, now here's the second one, the probability challenge, which is quite a bit tougher. Most people don't know how to do this. So it's not a matter of doing it in their head, they just don't know how to do it. So, you're in Las Vegas and someone presents you with a gambling proposition. You choose one or two ways to roll 2 dice to see if you win a prize, and he'll pick the other one. Here are the 2 possibilities. You roll 1 6-sided die. If you get a 4, 5, or 6, you win. Or you roll 2 6-sided dice. If you get a 5 or a 6 on either or both dice, you win. And if you both win, you roll again. So which is the better choice for you? It's easy to figure out the first one because 3 out of 6 is half or 50%. The second one is much harder. Now, it's not hard to see that the chances of rolling a 5 or a 6 on one die is 1/3 or 33%. But what about when you're rolling 2 dice? You can't add percentages together. In this case, if you're rolling figuring out the chance of not rolling a 5 or a 6, it'd be 2/3, and if you add them together, you'd get 4/3, and that's more than certainty, which is 3/3. You don't add them together. You multiply. So, you multiply 2/3 times 2/3, and that's 4/9. Well, if there's 4/9 chance of failing, there must be a 5/9 chance of success because all the chances have it add to 1. So, you want to take the 2 dice and roll a 5 or a 6 on one or both because you have a better chance of winning. In fact, there's one chance that both rolls will succeed, 4 chances that one will succeed, and 4 chances that neither will succeed. If you can't figure out simple probabilities and understand simple stats, then you have some work to do to be an efficient game designer. This is only a start about probability, of course. See James Ernest's article for more details. It's something that you really need to read rather than hear, because you'll probably want to read over it several times in order to understand exactly what he's talking about.